So I'm going to be talking a bit about particle collisions today, and probably bounce to a number of other things as well. Um, so particle collisions can happen for GPU or CPU particles. For CPU particles, it does a really simplified check against the world as the particle moves and bounces off. It's not the cheapest thing in the world. It's one of those things that we tend to leave for only high quality settings because of the CPU cost for doing the collisions, especially if you have a lot of them or if they're doing very complex things. So inside the particle system, we tend to have um, uh, settings that reduce the amount of collisions it can have. Um, Create a really simple particle effect and drop in collisions to show you some of that. So with the default collision module for CPU particles, you can set the max number of collisions. So you can say, don't bounce more than once, and after that it'll ignore collisions or do whatever you tell it to. Or when it runs out of collisions, you can have it kill itself, freeze, or like I said, just halt collisions, which means the particle will then continue moving as if it never had collision on and go through things. So depending on what you want, you can get a lot of the settings tuned in, and then you can set it to ignore pawns. So if you don't want it to, or sorry, not decrement. So if you have your character running through a spray of sparks, you want the sparks to still continue colliding even after they bounce off the player. Turning off or turning on pawns do not decrement count means it doesn't bounces off of the player don't count against the max collisions. So you'll still get future bounces. And then there's values for whether or not this is something that will drop detail quickly. So if performance goes down or something like that, particle collisions can be one of the first things to go. And again, this is all the setup for CPU particles. So this being, if I add in acceleration and give it some downward force, say negative 500, my particle spray will drop. And when I drop it in my scene, there it is. My particles are set to kill. We'll up the number of max collisions to 3. And the damping factor is, you can think of it as a multiply my velocity based on this damping factor. So if it's 0, your velocity gets multiplied by 0, so it goes from whatever speed it was moving to 0. If it's 1, your damping factor, it's essentially perfect rubber. Anything that hits will get the exact amount of force back that it got coming in. So you get that impossible situation of a ball that bounces exactly back up to your hand every time. It doesn't lose force. So for the most part, we drop this down to around 0.5 or so, and you start getting that decreasing amount of force per bounce, and you get something that looks a little more like a real reaction to impact against the surface. I'll give myself a little bit of, whoa, a little too much velocity there. So you can see the arc of the bounce gives me something that looks like, a real object bouncing through the world. So these are kind of the default collision settings. When you start getting into GPU particles, you have some other options available to you. Because GPU particles, the simulation's done on the GPU, not on the CPU, our collisions are quite a bit different. So I've got a particle system. It's pretty much the same thing. It's kind of a fountain. If I drop this right into the scene, I get this spray of particles if the lifetime were long enough to actually reach the ground. So there, it lives for 4 seconds, goes through my ground. I'll go ahead and set the fixed bounds so that it actually has, there. So I can see it, it goes through the ground. It's just being a little unaggressive with the bounce. Let me set it manually. There we go. So now I can see the bounds, or I've set the bounds so that I can see the particles all the time. Now, if I were to turn on the normal GPU particle collision, that's done using the depth of the scene because the GPU already has that information. So it does a kind of simplified translation of the depth into trying to build surfaces, which works really well. One thing I need to do is I need to make a new material because the scene depth collisions like that require that the particle be translucent. If I just add it by default collision, you'll see it's X'd out. Scene depth collision cannot be used on emitters with an opaque material. So we'll fix that. We'll give us a procedural dot to work with. So I'm using a sphere mask, which, given the default UV coordinates, I'm evaluating it for 0.5, which will give me a location in the center, because it starts 0, 0 in one corner, goes 1 along one axis, or 0 to 1 along one axis, 0 to 1 along the other. So the center point is 0.5, which I have here. And then the radius is in the same space, so I want 0.5 radius. And that will give me a really crisp circle. Drop the hardness down to say 50%, and I'll get a nice soft dot that's procedurally generated, so there's no compression artifacts. I find that it works quite nicely. I'll bring in a particle color node, because really I just care about what the emissive color is, and then the opacity is being driven by the alpha channel multiplied by my sphere mask. So change the material to unlit and translucent, and we're good to go. So stop previewing. It feeds me a default of white for my particle color, so I get a nice preview of what my particle will look like. And then I will use that material for my particle system, and bang, it should work. It's compiling the shader, and now I have nice soft edge dots that are colliding with the scene depth. As soon as I changed the material type, it understood that the collision would work, and so the particle system's now working and colliding with the scene. Now, one artifact with scene depth collision is if the camera can't see it, the depth isn't being calculated. The buffer flat out doesn't contain data for surfaces that it can't see, whether that's because it's on the back side of something or not. So where you can see, if I can see the surface, it starts bouncing. You can actually see the outline of particles. As soon as I can't see the surface they should be colliding with, they just fall through. And that's true however it's set up. So if I give myself, like the other one, an initial velocity that takes me in a given direction. So let's just invert that so we're going there. So I have data here. I don't have data here because it's behind the pillar. If I move, I start getting collision. So this is one thing to keep in mind when you're dealing with particle collisions. On the GPU side, if you're using the scene depth or the defaults, your collisions will drop through things if they can't be seen. If I set the collision values to inside of my GPU particle collision, my resilience is at a slightly different default. This is the same thing as damping. It's how much force is returned to the particle on collision. If I set it to 0, my particles hit and then skate because they're not bouncing off, but they're continuing to collide. Unlike CPU particles, where the numbers of collisions are kept to a minimum because of performance, collisions for GPU particles are much, much cheaper, especially for this particular method of doing it. So we don't worry about limiting the total number of collisions. We just worry about how we're generating the collision data, where it's being used, and then you tune the values to get the kind of behavior you want. If I change the collision mode, it's kind of the same as for particle or CPU particles, except that I'm not waiting for a particular number of collisions to occur. I'm flat out saying, on your first one, die. So it just kills. And again, if I can't see it, the particle will live quite a bit longer. Not sure how well you can see it over the stream, but the particles are going right through the floor because I'm not colliding correctly, or I'm not colliding successfully because it's off screen. As soon as they come back on screen, it dies. Or you can set it to stop. And this can be kind of fun if you're doing something where you want to paint with your particles. So I've set up my particle system to stop on collision, and I can now draw on the ground. There we go. So now wherever the particles collide, they just freeze. They continue to live out their life, so they'll fade off at their normal rate, which is set by the default color over life, but they'll do that without ever moving again. Now, one thing to keep in mind is that stopping, it's basically still sitting there colliding. So by doing this, you'll notice wherever I kind of write over that collision data, the particles fall through because they're no longer colliding, so they no longer stop, and kind of lets me erase my my drawn on the floor stuff. So something to be aware if you're using the particle collision for GPU sprites, using scene depth is, even after it's collided, if the thing that it's colliding with goes out of view or is covered up by something else that writes to scene depth, you may get some artifacts from that as well. Now, given that, there's a feature in the engine called distance field, which is essentially building a volume texture of an object and its presence in the world. If I turn that on by going into, first you have to turn it on in the project settings. So I'll bring those in. Under rendering, there's a, here it is. Under lighting, it's a generate mesh distance fields. We use these in a number of different ways. We can use it for ambient occlusion. We can use it for material effects where you know that two objects are coming near each other, not even touching it, but just near, and their surfaces can react to each other, things like that. In this case, we're going to be specifically using it for collision, but it does have a lot of other usage. Because it generates volume textures for each object, the memory use does go up. So if you're doing something on mobile, you wouldn't use it at all. Or if you have a very limited platform that you're targeting, for whatever reason, it's something to consider very carefully. It will also, when you first turn it on, it will have to go through all of your meshes in your project, or specifically the ones that are loaded, and generate that distance field, because it isn't something we don't generate that data unless we need it. So given that, if you turn it on the next time, it'll prompt you to restart your project. When you do, you'll have a longer initial load time the first time because it's going to generate that mesh distance field data. Once that's done, however, I'll close this. Under Show in Visualize, there's a Mesh Distance Fields checkbox. With that on, your world gets significantly more ghostly. This is that volume representation of the object and its nearby influences, or what it can potentially influence nearby. You can see it's not extremely high resolution because it doesn't need to be. We can basically do a lot of analytical calculations to work out influences, nearby data, things like that, and which is what we're doing with the collision for particle systems. So even though, like the floor, that distance field that I seem to be sinking into, that's the one for the box that makes up the ground. So even though I'm visibly inside of it, when I go into my particle system and change my collision over from scene depth to distance field, I'm not going to be colliding with the very top of that uh, distance field where it's starting to build up. The system is doing it in such a way that it's kind of analytically reducing that down to what we see as the surface. And you can change some of the values in the particle system to affect that. But now, as I draw on my floor, it's no longer doing its erasing trick because that data is there whether or not I can see it. And this gives me collision. It's not perfect. You can see particles occasionally do make it through. It is an analytical reaction to finding the surface. It's not as coherent a data set as the scene depth, but it is persistent all the time. And it works with dynamic objects, so you can see as I move it in and out. It can also be used to do higher resolution per asset. So if I open up the properties for this cube, I'll turn distance field visualizing back on. There. So you can actually see how the data is a bit noisy because it's doing a really low resolution 3D representation of the surfaces and the distance out from them. In your build settings, you can increase that resolution. You need to be very careful with this. It dramatically increases the computation time for generating that distance field data. And this is very dependent on the complexity and size of the object. For something small, like this cube, I apply changes, I wait a couple seconds, it'll build the distance field, and now you can see the representation is much, much cleaner than it was before. So for some objects, this may make sense depending on your use of distance fields. If I drop this to 0.5 and apply, it's really quick, but my data is not going to be all that great. It's going to be noisier again. So it's something to be aware of and be careful with. So somebody asked if disabling tangent space normals in the material editor does it help with reducing instructions when no normal map is used. It shouldn't make a difference when no normal map is used. It will reduce instructions by, I think, 1 or 2 because it doesn't have to do the matrix math to transform the vector. Generally speaking, it's not going to be something that's going to make a major difference in most projects, and it will make using normals for your average artist more difficult because they're used to working in tangent space. The reason that's there is because when we first started working in UE4 with the G-buffer and a lot of the normals being in world space, it was more difficult to transition the artist in from working in tangent space normals and then requiring them to transform them before they fed them into the normal map input. So it made more sense to just default to doing that coercion from the get-go, and it made more sense. So you could save a couple of instructions. In most cases, it's probably not going to be a significant win. Somebody also asked, would distance field collision be performant enough to be viable in a complete game, something like UT or Paragon? Yes, provided you budget for it. These are things where because we're using distance fields for other things as well, like ambient occlusion, the data already being there means we can just leverage it for using for other features, like in this case, collision. The collision is very performant. I mean, we have GPU particle systems that are quite extensive in terms of particle counts. If I, let's say, add a sphere here to the location and give it a little bit of velocity. And the reason it looks completely wrong in the particle editor is because this scene inside the viewport doesn't have distance field data generated for it, so it basically thinks it's colliding all the time. So there we go. So I have all of these particles spawning at once. There's 2,000 here. If I up this to, let's say, 5,000 per second instead of 500, I'm still colliding a very large number of particles with my scene. You can see there is some failure where it just has too many particles. Some of them fail to collide, but for the most part, it's a very efficient, effective method of getting particle collision that just works and isn't view dependent, which can be very important. Also reduce the size of these so that they don't overwhelm each other quite so much. Of course, you can also do velocity-based stuff. So I'll change the sprites to be velocity facing and make them a little longer along their motion vector. So now they're slightly streaky, and when they come to a stop, you can see. Now, again, because the distance field is a pretty simplified representation of the object, you do get some inaccuracies with the surface that are based on the mesh's position. Again, you can improve that a bit by increasing the distance field resolution. You can see it's a little more accurate now than it was before, and it's not as likely to have those kind of pit artifacts. But again, this isn't something you want to do kind of wholesale with your scene because, one, you're increasing the amount of memory used for the distance fields. Two, anytime the distance field has to be rebuilt, it's going to take longer. So it's not something you want to do constantly. Because it's per object or per asset, and every mesh with that data is going to be rebuilt. We store a single distance field for the object, not for the instances in the world, so you need to be aware of that. It's something that anywhere it's used, you're going to have that resolution of distance field stored in the scene or visible in the scene. Again, there's visualization modes, so if you want to see the distance fields, you can here. And flipping back to use defaults. There we go. So inside of the collision for the distance field collision, we have the radius scale and bias. So if I reduce the radius scale, you can see this is sitting pretty much flat on, so it's interpenetrating. If I increase this to about 3, when the particles hit, they're sitting slightly higher because I'm basically inflating the size of the particle in terms of its collision response. So if you have something where your particles need to kind of land and be somewhat flush on the surface, and you're getting a lot of Z-clipping, increasing the radius scale a little bit can help with that quite a bit. Somebody asked if it's possible to combine distance field and scene depth collision for both cases of visible and non-visible particles. Would that help or hurt performance if it was implemented? I think you can only have a single particle collision module. There's nothing to prevent you from having, or they don't stack. So I'm not getting both kinds of collision. It's just the last one in the stack, the bottommost one in the stack is doing all the work. The one above it gets discarded. But there's nothing to stop you from, say, duplicating the emitter and changing this to be scene depth. So now I'm getting both behaviors in a single particle system. If I change the resilience on the scene depth one there. So you can have both in a single particle system, but it's not, there's no win there. You're still doing all the collisions and stuff like that. So one other thing that you can do if you want to mix and match particle systems together is, let me get rid of this particle system completely, and I'm going to create a new CPU particle that we spawn a little less frequently. We're going to send it down a single vector. So there, it's just puffing away, and we'll give it an increased lifetime. I'm going to name this particle system to source, and I'm going to create a new particle system, which will be GPU particles, so I can spawn a whole bunch of them. I'm going to change the initial color over life to be, say, dramatically blue, just because I happen to have it here. So now I have a blue particle system. And I'm going to set its size to be something smaller. And we're going to up the spawn rate by quite a bit. So I want one particle to attach to another. So inside of the GPU particle, I'm going to tell it its initial location is source. So now, as my particles are spawned and moved, I'm spawning, or as my bigger particles are created and move, I'm spawning the smaller GPU sprites from those. And now I can do things like set my initial size to be a sphere, and let's say it's about 5. Let's do 15. There. So now it's roughly the same size as my source particle. If I reduce my spawn rate even further, more of my particles will get spawned from those new ones. You'll notice that until that first particle gets spawned, it just spawns from its normal location because it doesn't have anywhere to offset from. We could also go into this initial location and tell it to inherit the source velocity. And now it tries to move at the same rate as its parent. And of course you can scale that. So if you want just some inheritance, it's going at 0.25 or 0. So now particle, wherever it gets spawned, it stays in that same relative space because I'm essentially no longer inheriting that particle location. If I set it to sequential, it will create new particles at each new location as it can. Really, with this kind of system, that sequential versus random for the selection method makes no difference. And for the most part, unless you're spawning singular particles and trying to make sure that they are tied together, which I haven't really ever had to do, it's not something you're going to find a whole lot of use from. But inside of this system, I can still do all the same collisions. So I'll set the lifetime to be a little longer. And I'll turn my collision back on. And again, the default collision is the scene depth. So now I'm spawning my CPU particles. My GPU particles are kicking along with them and colliding with the scene correctly. So this is a good way of having something like a specifically controllable spark, something that you need the control that you have of the CPU particle, but you want to increase its effect, increase the number of particles, things like that. If I were to get rid of my initial velocities here and my acceleration, I would basically have a nice trail. If I go into the inherit source velocity and give it a little bit of a negative value, I can actually have them move back a bit. And I'll give this a bit of a random range. So now they'll spit off in a variety of different directions. So you can get quite a few complicated effects. And then, of course, because collision is on for this, if anything walked in, I could have it kick the trail around. And again, depending on the kind of object, if I set my collision to be distance field instead of scene depth, and give it a minute to work. So now my particles are moving and bouncing off. They're not going to be displaced. I'm not imparting physics on them, but it does give me, anytime the particle's moving and it hits something that the distance field says, oh, you're inside of me to a certain degree, it will get moved and kicked out of the way. You can also set this up so that you can use opaque particles. One of the things that, like I showed, having to rebuild the material or make a new material for it, was that the default collision, the scene depth, requires that it be translucent. If I set this to be masked and hook this up there, I'll also change the hardness to be 0, since that will give me a full gradient dot. If I just preview this. So really all I'm doing is saying at some point on this surface, clip and become opaque. So now compiling this, my material is masked. My particles will still collide because they're just doing the distance field calculation based on the particle and the surface, and I get nice collisions off. And I don't have to pay for the overdraw cost for a mass or for a translucent particle if for some reason I don't want to. So that can be pretty useful in and of itself, the ability to use any material type essentially and not be limited in that way. One of the other things that we do pretty often with GPU particles, and I keep creating these from scratch, something like sparks, where you want to have a velocity that moves at a given speed, or a particle that moves at a given speed and changes size when it hits. So you have the fast-moving long streak that shortens as it hits. It's pretty easy to do. It's not necessarily based on collision, but it does have something to do with some of the collision settings. So I'll set it to be velocity. I'm going to do size by speed. And what that's going to do is it's going to, based on the speed scale, it's going to stretch out to a maximum scale. So y being my my direction of movement for particles. If I set this, and these are typically really small numbers, so you can see it's starting to become ovoid. I'm going to change the default sizes to be, say, 4 and 8. So now I have long-ish streaks. I'll spawn quite a few more of these and turn it into a GPU particle system so it'll work the way I intend it to. And set up a new velocity so that I'm going somewhere controllable. And I use spheres a lot to do just simple offsets so that I can get a cone spray or something like that by just defaulting to that. And looking at my axes, I can see I'm moving down positive x. I don't want particles to go back if I turn on velocities for my sphere. So I'll just turn off negative x, and now I'm not spawning in this hemisphere at all. And by adding some velocity scale, say about 3, I have a cone spray that it's not fighting that initial velocity down the vector that it was being given. Now by setting an acceleration vector, I'll get a bit of drop to my cone. And let's give it some color over life that looks like a little bit of a welding spark. So I'm going to do this all with fading. So I deleted the endpoint, and I'm just going to set this essentially as a constant color. Not worried about getting this too particularly correct. I'm sure there's a ton of other work I could do in the material to get this to look like it was had a hotter core and gave it some more noise behavior and things like that. But now we'll set up the collision. I actually do want this to start in scene depth, so I'm going to go ahead and change this material back to translucent. And I didn't break the original opacity, so just changing the blend mode will work just fine for what I'm doing. So now I hit, and because I'm keeping most of my velocity, I'm not losing a lot of my size, specifically my size along its length. Now, if I go back in and make sure that my sizes are roughly equivalent and do a lot more of the stretching inside of my size by speed, and bring that value up a bit. Now, in my collision module, the less I return back in resilience, the shorter I expect my particles to get. I wonder if it's not working because I added it by... Oh, wrong one. Try this again. Seem to be getting results I don't expect. There, it's getting short right before it stops completely. I'm not losing quite enough velocity over its time, so we'll kick up that initial velocity. And move the particles here to collide. Oops, there we go. There we go. Whoops. Accidentally went to somebody's bookmark. So now my particles are stretched quite a bit before they hit the wall, and then when they hit the wall, they get shorter and then longer as they fall down to the ground, and then when they come to a stop, or a near stop, they lose a lot of their scaling. So this is how we would do something where the particle noticeably changes shape based on collisions and velocities. If we were doing it completely in CPU particles, we actually have events for collisions. So if I turn this off and do a new particle sprite and add collision, go ahead and give it the same particle. Oh, it's already got it. And then I can add an event generator and say this event that I'm going to do is on collision, and say this. Give it a name of this. Say it's got an acceleration down. Not quite that far. And then on collision, we're going to kill it. Okay. Make sure we're hitting the ground. And I'll drop the spawn rate to, say, 5 so that we can see the individual particles. And then I'm going to create a new particle system, disable the spawn rate, and add an event receiver called spawn. And say, I want you to spawn 15, whoa, not 165, not 154, 15 particles. And it's looking for a collision named this. So now every time this particle drips and hits the ground, it goes and spawns. And then we can do things, so let's say we can inherit the velocity, and now when it hits, they'll go down at the same speed. And of course, just like we did before, I can change the inheritance. And the fun part with this is I can change it to be negative. So I can say X and Y, I want the same, but on Z, it gives a negative value. So I can kick up at the same strength that it's kicking down. So now I can kill the velocity here and add a little bit of velocity there. And now my particles will differentiate a little bit based on their received velocities. So now my particles will tend to go further along the vector of the particle that drops. So if it hits the surface normal like this, it's going to get accelerated along X or Y, but decelerated negatively along Z. So if we get even a little more and accelerate even more, we can get a nice skittering effect where they hit the ground and scatter out a little bit. And we can always add more behavior here. So the more the particles go outward on spawn, the more they scatter. So we can start getting that kind of traditional welding thing where the spark comes down, and then because the metal breaks and it releases energy when the spatter breaks, it goes skittering off. We can start getting to that pretty quickly by doing velocity and now I'm spawning quite a bit, quite a large number of particles when they hit compared to what's going on. We can always add a little bit more random behavior on the spawn so we get some breakup when they hit and go off in different directions. And we can still do this, I believe, I haven't tried this in quite a while with GPU sprites. So we can spawn GPU sprites on collision with the ground. They just don't inherit the velocities quite the same way. So you'd have to do a little more work, but you can get there and get quite a bit going on. So any questions so far? I don't seem to have anything currently popped over into the QA questions window that Alex has been kind enough to keep populated for me. Most of the stuff that we do with particle collision is pretty controlled. A lot of the CPU stuff has a noticeable cost on the CPU side, so we try and keep that minimal. We also try to keep it completely non-gameplay impactful, because for one thing, if it's a thing that we drop, you saw the drop detail checkbox in collision. If it's something where we're not dropping detail, then that's a performance cost that we're paying all the time, or at least all the time that particle system is active. On top of that, if it is gameplay relevant but drop detail is off, your gameplay may change, or at least your interpretation of gameplay may change. Suddenly, either through users changing detail settings or a performance drop during gameplay. Something like these drips, if this drip was used to indicate where damage occurred, you'd want to have something there as well that indicated that damage, not just the particle system telling you all of the information. You want other things giving you that as well. Now, pretty much everything I've shown has been sprite-based, mostly because we don't have GPU mesh particles. So I've stuck with that. You can do a lot, especially the event stuff, with meshes. So if you wanted to have more of a water drop splash where it spawns like a mesh ripple or something like that on the ground, you can easily do that as well. We've used that in some. Yes, my beard is gone. Somebody just beard? Question mark. It will be back. It wasn't in a good place this morning, and since I knew I was going to have to be on camera, I went, heck with it, I'll shave it off. So for the water droplets, I've done some of that stuff in UT, so that and matter of fact, we did it in Gears as well. Just spawning a stream of particles down, wherever they collide, you get some kind of chaotic splash effect. When the player walks through, it'll splash on him. It can look really good. You just have to balance that against the other performance needs of the environment that you're working in, right? If you're something that's very particle heavy, you may not want to have it on. You may want to make a duplicate of that particle system without the collision that just assumes a static, I'm going to be 220 units down, I'm going to do a splash, and I'll just kill the particles when they reach that height. That's totally acceptable. We do that kind of thing all the time. So one thing I was playing around with a little bit before in kind of figuring out what I was going to talk about is there's quite a few particle material modules. If you just start typing particle, you can see there's a number: particle color, particle direction, particle motion blur, fade, radius, random, things like that. Particle direction is pretty interesting because it actually does give you the color, the vector of the particle's motion as a color. And this works really well with GPU particles. Yes, I'm deleting these particle systems. So right now I'm kicking along one direction, which means my vector in space is along that vector. As I rotate it, well, if I didn't accidentally hide it, so as I rotate it, you can actually see the color of the particle system is changing based on the individual particle's velocity. So you can use this to say particles that are going up are going to get this particular material result. Particles that are going down are going to get this one, all within the same system. Somebody asked, can you show the whole sphere mask material again? Of course. So it's pretty simple. Essentially what you have is a comparison between A and B, which gives you a result that is technically a sphere. It's giving you a 3D result, but in a 2D plane because I'm just feeding in a 2D texture coordinate. So 0, 0 to 1, 0 to 0, 1 to 1, 1 in the corner. At the midpoint, where both x and y are at 0.5, is directly in the center. So I'm saying, give me a result that maps to the center of this texture coordinate, and then give me a radius off of that to create my sphere. So I'm saying, this is the point in space in a 2D plane where I want to start this sphere result. And then my radius is how far out in this case in UV space am I going to create that radius. And then the hardness is, if the hardness is 100, then I get a sharp edged sphere. It's a little easier on a box, more than likely. There. So I get a perfectly crisp edge. Make sure I'm previewing this so you can actually see it. And as this hardness value drops, that edge will get softer and softer. One thing you can also do is this, because this is a 2D result from a 3D calculation, you can do this as a 3D calculation as well. So if I do world position as one of my comparisons, and then we'll do a vector parameter as the second, and then scalar parameter as the radius, and we'll say this is going to be 100. So now I'm looking for the intersection between a position in space and this user-defined location, and I care about a sphere 100 units in radius. I'm going to get rid of some of this particle derived behavior. I'll set it to be an emissive value of 1. So now you'll notice my dot looks pretty much exactly the same. That's because the cube happens to be, or the plane happens to be about 100 units square, which means, or what, 200 units square, which means my radius from the center point to the outer edge of the plane is 100 units, so I'm getting the nice thing. If I go into here and start manipulating these values, that's a little too much. I'm changing the point in space. I should have given it a chance to finish compiling. I'm changing the point in space that I care about the comparison. Now, I'm actually moving along the x vector, which means my slice result of that sphere is changing. I'm actually going to use this result as a lerp and give myself a little bit of opacity. So there, now you can see where the original sphere was. So I'm moving this result that I care about around in 3D space. If I say go 25 units along x, or negative 50, I'm moving in that value as well. So now I'm moving up or down. And the fun part of this comes when you actually put it in the world. So I'll grab one of my cubes here and toss my material on. Now, it's not going to look like much until I get it somewhere useful. So I'm going to create a material instance of this and open it up and apply it to the material. I'm also going to zero out my transform for this cube because I want to start at world center. You can see as I move my cube around, everywhere it's intersecting the particular point in space that I care about, I'll get a result. So let me override my vector parameter and move it up. There. So I'm literally moving a sphere of opacity around in 3D space. Depending on what I do with these values, it moves in different directions. And then if I increase the radius, I'll actually increase the size of that sphere. So if I apply this material to enough things, and we'll get them over here by, there we go. So now as I start moving those values around, you'll see that sphere consistently applied to all of the objects in the scene. And this can come in really handy with a number of things. You can do this with a particle system so that if your particles leave like the center of the actor, because you could use the actor's location instead of the vector that I exposed. You set it up that way. You can say my particles, as they leave this core, just stop rendering. Not always the most efficient thing, since they're technically still rendering. You'll still incur overdraw cost for them, but it can be used to kind of constrain effects. You can also use it to do, and I think I've done this in another Twitch stream, location-based opacity. So if you have, say, an explosion and it's supposed to temporarily remove objects and then collapse back down, or interpolate between two different material states on the surface, you could easily do that. Like here I'm doing it in opacity, but it's totally not screen location based. I could do it so that it's opaque and my lerp is between two color values, red and blue. And we'll feed this into the base color. Holding Alt instead of spacebar would be useful. And set this to default lit. Compile. And now wherever that sphere is valid, I'll have one color, and wherever it's not affecting things, I get another. So you can use this for a whole lot of things. Again, if I change the radius, I can make it really small. And you can see how much or how little it affects the scene based on these values. So it can come in really handy, not just for particles, but for all sorts of stuff. All right, I think that pretty much covers everything that I had on my agenda, which really was just the particle collision stuff. So the other material stuff was kind of just an interesting tangent to ride off on. I hope people found it entertaining and informative, and I look forward to doing this again soon. Thank you, Clint.